The previous video was supposed to be about sort of the concepts behind graphing and the way that the coefficients work in these graphs. And in this video, I'm really talking about like example problems of how we do this. So I know this is kind of daunting, but I really wanted to be specific about what the steps are for this process. So I'll go through the steps here, and then we've got 3 examples that we'll look at. So step number 1, compute the 4 parameters that were listed in the previous video. So before you do anything, find the amplitude, find the vertical shift, find the phase shift, and find the period of those trig functions. If you forgot how to do that, go back and watch the last few minutes of the previous video. Step 2, plot that new origin using the vertical and the phase shifts, and then draw vertical and horizontal dotted lines through them. So what I mean by that, and I'm going to sort of overlay an example of this on top of this. Suppose that you had, this was the origin of your graph, right? And when you shifted, you found that you were going to shift to the right 2 and up 3. So this is sort of going to be your new origin. You're going to draw a dotted line through that and a horizontal line through it. I hope you can sort of see that. And the idea is that you're going to treat this point like the origin for the sake of graphing, right? So now we go on. Next, you're going to draw horizontal dotted lines at an amplitude's height above and below that equilibrium line. So let's say that your amplitude was like, say, 2. You'd go up 2 and put a dotted line up here. You'd go down 2 from equilibrium and put a dotted line down here. And the idea behind all of this is that what we're doing is we're sort of saying, like, well, this is going to be the left bound of one of the periods. This is going to be the bottom bound. This is going to be the upper bound. This is sort of my equilibrium line. And so then the idea is that when you do that, if it's a sine or cosine graph, sine or cosine is going to fit inside here. And if it's secant or cosecant, then those are going to be the lines that you have your u's going, above and below. So then the last thing you do is you draw another vertical line a period's length away from your new origin. So your new origin was here. Whatever your period may be, come over here and draw a dotted line here. And I imagine it's sort of hard to see on top of this, but the idea is you end up with this rectangle in the middle here with a dotted line going through the middle of it. And you can then fit, like I said, actually the 5th step is to break that period into 4 subsections. So I'll use a different color to show you this better. Sort of cut it in half, cut each of those halves in half. And then you can even see the 1, 2, 3, 4 subsections, and you can either fit sine into that region, or you can fit cosine into the region, or you can sort of fake draw those in and then draw your secant or cosecant curves around it. So my strategy on these is sort of use all these parameters to draw this rectangle that'll allow you to fit one period's length in there. And then once you have that, you can sort of copy that same shape on both sides to draw the entire thing. So these are the steps I'm going to use, and I'm going to try and illustrate them through the next few examples. So let's take a look at those. If you have graph paper, I definitely recommend that you use it for this. I'm going to try and come up with some graph paper here, so we'll see if I'm successful there in just a minute. If you have normal graph paper, a recommendation that I would make, that I've heard from other math analysis teachers that have done this more, is that you can use a grid and make each grid worth 0.5. The reason that's worth doing is that when you're working with numbers like pi, well, we know that pi is, we'll say roughly 3, which means that pi is going to represent 6 boxes on your graph. And it's not exact, but it lets you work with something there. So if you make each of your boxes worth a half, it can be easier to sort of fit the whole thing on. But before you try and draw a graph, I really think it's worth, identifying what those 4 pieces of information are. Right? So those 4 pieces of information, remember, were the amplitude. An amplitude for this problem, remember, we find that by taking the coefficient in front of the thing. So the amplitude here is 3. Right? Next step is the vertical shift. Okay. Well, the vertical shift is based entirely on the end number, -1, and that -1 means that I'm going to be shifting down 1. Next, I'll go ahead and identify the period. And I change the order of these from time to time, that's okay. The period length, remember, we find by taking the natural period of this function. So recall, what is the natural period of cosine? The natural period is 2 pi. And then we divide by the coefficient of x. Since that's a 2, I'm dividing by 2. So the period of this thing is pi. Okay? So then the last thing is my phase shift. And the phase shift for this thing we find by taking the number that's added on the end of this thing and dividing by the coefficient. So my phase shift is pi over 2, and because it's positive, remember this works quote-unquote backwards, pi over 2, it's going to move to the left, right? Because it has to compensate for the idea that this is positive, so it feels like it's moving in the wrong direction. So this is all of my information about this graph. So now when you go to your graph paper, you can sort of start to imagine, like, you know, you're going to be shifting down 1, from there you're going to be going up and down 3, so it gives you a sense for sort of how tall your graph has to be. Then the period is only pi. In other words, it's only going to be 3 units. Like, one period length is only going to be 3 units wide, and the thing has been shifted to the left by pi. It's been shifted to the left by 1.5. So this is going to, I mean, you know, this will sort of be a box-shaped graph, and at this point you can go to your graph paper and start to try and graph these things. In fact, I'd like to say pause the video, try and walk through the 5 steps I listed on the previous page, and see if you can come up with what this graph looks like. Okay, so I've provided myself with a piece of graph paper here, and I'll go ahead and start walking through this. So the first thing I said that we should do is we should think about how the origin shifts, right? So I'm going to sort of use purple as my color for defining the boundaries for this thing. So I'm supposed to shift to the left by pi over 2, so the left by pi over 2, that's 1.5. So I'm 1.5 to the left, and then down by 1. This is sort of the new origin for my graph. So I know I'm going to sort of have this as the left boundary for one period, this as my equilibrium value, right? After that, we said we were going to go above and below that by the amplitude, right? So from this equilibrium line, I'm going to go up 3, so up to positive 2, and then down 3, so down to negative 4. So those define my sort of top and bottom boundaries for the region I'm working with. Right? Then the last thing I do is I take this period value, right? So I'm going to go pi to the right of this value. So if I was pi over 2 to the left, I'm basically going pi over 2 to the right as well. So I'm going from negative 1.5 over here to, you know, positive 1.5-ish. I'll draw my dotted line here. And the idea is I now have this rectangle with an equilibrium line in it that I can fit my graph into. Last part of this, I suppose, is we talked about the idea of, you know, sort of cutting this into 4 equal segments so that I can really fit the graph into this space. Right? Now, I did kind of forget what the graph was. Okay, so it's supposed to be a cosine graph. So it's 3, and it's a positive 3 cosine graph. So that means I'm going to be starting up at the top in this box, coming down for the first point, all the way down for the next one, up to the next one, up to the next one, and that gives me 1 period's length of cosine, right? And from this point, now that you have this, you can even go on and do it again. You know, if this was 1.5, you could go over here to, you know, pi over here, 4.5, and again, sort of, you know, cut this into even segments, and there's no reason that you can't draw another one of these things. Once you've got one of them, you can sort of just repeat, you know, the shape that you have to continue graphing these things in both directions. So that's an example of one of these. We've got 2 more coming up. So if you're up for it, I'd say recommend, you know, walk through this one on your own, find the 4 pieces of information, then watch the video, make sure you've got them right, and then go to the graph. So the first thing we're identifying here is amplitude. The amplitude of this graph, we've got to be careful here. The amplitude is a thing that's multiplied right in front of sine, so that's right here. So the amplitude, that's based on that negative 1 value, the amplitude is 1, right? What is the vertical shift? Well, vertical shift is the number that's added on the end. There's nothing added on the end, but there is something added on the front. The thing added on the front is a 2, so my vertical shift is going to be up 2. Right? Next is period. Okay, period length is supposed to be the natural period, that's 2 pi, divided by the coefficient of x, which is 1/3. So the period of this thing is 6 pi. So that's a pretty long graph, and it's like 18 units long. That's fine. It is what it is. The last thing we need to write down is we need to write down what the phase shift is. So phase shift. Phase shift we're supposed to get by taking our, you know, the negative 1 on the end there. So negative 1, and dividing it by the 1/3. So my phase shift is negative 3, and so that negative tells us effectively that we're going to be shifting to the right by 3. So this phase shift of negative 3 means I'm going 3 to the right. And that's all of the information that I'm going to use to graph this thing. So now again, think about how wide your graph needs to be, think about how tall it needs to be, sort of give some thought to how you're going to graph this thing, and then, chunk out a section of graph paper for yourself. Alright, here we go. I'm not going to lie, I'm not very excited about graphing this one because it's going to be a really weird shape, but that's okay, we'll do the best we can. And my sense of this is always, you're not going for a pretty graph. What I'm looking for is, do you understand how these things are supposed to work? Do you understand how you would come up with what this graph looks like? So, let's see if we can do it. So first, we're supposed to sort of shift our origin. We shift 3 to the right, and we shift 2 up. So 3 to the right, 2 up puts our new origin here, which means this is going to be sort of the left bound of my rectangle, and then I have my new equilibrium line here, 2 units up. Okay. Next up is the amplitude. The amplitude is only 1. So I'm actually going to zoom in on my graph a little bit so I can at least draw a little bit better maybe. So above by 1 and below by 1, and then we recall the period length was 6 pi, which is 18 units. So if I started here at 3, I'm going to end roughly over here at 21. Might even be as much as 22, but again, we're looking for a sense of this graph. So your rectangle ends over here. Next up, we're supposed to take this thing, we're supposed to split it, down the middle. So we could go 9 units over, so we could go 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. So, over here at roughly 12 is where the middle of the period of this thing is going to be. If we go over 4.5, 1, 2, 3, 4.5, there's where that one is. 1, 2, 3, 4.5 is this one. So those sort of give me my breakpoints in the middle of this thing, and then I forgot what I'm actually graphing. I'm actually graphing sine. Okay, so we'll go back in here so we can see it better and draw a sine for ourselves. And it was negative sine. Okay, so we got to be careful with negative sine. So negative sine means I'm starting out here. I'm supposed to go down to this one, back up to equilibrium, up to the top, and then back down again. So you can definitely see the sine shape, but it's incredibly stretched. Right? And it makes sense. I mean, if you think back to what this graph originally was, this graph was originally asking about the sine of x over 3. I've literally made it 3 times wider, which is going to feel like it's, 1/3 as tall. So that's the example of that one. We've got one more coming up. So I really wanted us to have one example of secant or cosecant, and I don't feel like these problems are going to come up in a really, really complicated way, but I do think that we should be aware of it, and I think we should be able to use the principles we've done before to do this problem. So, as before, let's walk through these things. So you find the 4 pieces of information, check back, and then graph it on your own. So first up is amplitude. The amplitude of this thing is 1. After that, we have our vertical shift. Our vertical shift is 0, and kept it nice for us. After that is the period of the graph. The natural period of secant is 2 pi, so I have 2 pi over pi, which is 2. And then the last thing we have is our phase shift. And our phase shift is pi over pi, which is 1. And since it's positive 1, it's going to be 1 to the left. So these are all really nice numbers to work with. We should be able to come up with a decent looking graph of this thing. So sort of think about what your graph size needs to be, and chunk out a section of graph paper that you can use for that. Okay, so here we go. First we shift our origin. We don't shift up and down at all, but we do shift 1 unit to the left. So this sort of represents the left side of equilibrium for us. That's not necessarily a vertical asymptote, that's just me saying that's the left side of the box that I'm going to be working with. Okay. From there we go amplitude, up and down. Oh, so I'm sorry, so we have our equilibrium line running to the middle. Our amplitude was only 1, so I'm going up 1, and I'm going down 1. Period length is 2, so I can come over 2 from here to say that the right side of this thing is going to be here. Okay. Next up, we take this region and we break it into 4 sections. So I've got, here, here, and here. Then my thought was, within this box, go ahead and draw the associated function. So because this is secant, it's associated with cosine. It's actually associated with negative cosine. So I'm going to sort of draw a dotted negative cosine graph in here. And the reason we do that is that now gives us a framework for the rest of this thing. And in fact, to be honest, I'm kind of tempted to do another one of these next to it so we can see it. The idea is we know that the cosine graph would continue to do this every 2 units, right? So then from 3 to 4 it would go up, and from 4 to 5 back down. We could have something like this happening. And what we remember about this is wherever this curve crosses equilibrium, that's effectively a 0, and wherever we have a 0, we're going to have a vertical asymptote. So I'm going to have vertical asymptotes all over the place for this secant. There will be one of them here. I'm now using black so that we can sort of see this better. Another one of them here. Another one here. To be honest, it's like every 1 unit you've got another vertical asymptote running through the graph. There's a lot of them here. I hope this isn't too busy for us to see what's happening. That one was horribly not straight. Once you have those things in place, the idea was that wherever cosine has a bump, that bump will sort of be inverted, and you guys hopefully remember the reason for that. This height here is like 1/2. The reciprocal of that's going to be 2. When you have a height of 1/10, that's going to give you 10. That's off the charts. Right, so we can now go back and sort of fill in where the U-shapes are going to be based on my sort of dotted purple sketch of the cosine that fits inside of the box. You don't have to draw all of these at this point. I just, I feel like I've gone this far. I might as well sort of finish it out. And there we go. That's my graph of negative secant of pi x plus pi. So that's the end of the video. I know it was a little bit long, but hopefully that practice gave you a good sense of it, and I hope you guys got them right. If you didn't, please try and identify what it was that you had trouble with, and like I've said, write that question down so that we can talk about it. I'll see you in class.